Today we'll work on Leecode 1326, the minimum number of taps to open to water a garden. So this is a very interesting question and needs some thinking to convert it to some existing problem. Let's see. So we're given a one-dimensional garden on the x-axis. The garden starts at point 0 and ends at point n. And so the length of the garden is n. So there are plus 1 taps located at points 0, 1 until n in the garden. We can see that from this figure. For example, from position 0 to position 5, there are 6 taps, and each one has some number. For example, it has 3 for 0. It means it can water from 0 minus 3 to 0 plus 3. So it's from negative 3 to positive 3 actually. I think the drawing you need to see this line. This is for the first one, right? So I can actually draw it here. So we have some positions, and each position has a tab. And we actually know for each tab, for example, for this one, the water range is this range. And for this one, it can water like this range, okay? And maybe for this one, it can water a larger range, etc. So we need to select the smallest number of taps so that all the garden can be watered. So for this one, it seems we just need to select the tab at number 1, right? Because it can cover from minus 3 until positive 5. So the output will be 1. In order to solve this problem, we actually can manually change those ranges to these. Each of these is a segment. For example, we have a list of segments, and we want to cover a region. Remember that for all the segment related question, the standard way is to sort those segments. So for this question, it also works this way. So we just change the ranges to segments, then sort them based on a left hand and right hand. Okay? Then we can compare. So for example, we can compare every segment. If the segment can cover some position, then we will update the farthest. If a segment can cover current position, then what we do is to update the furthest position. If it can not cover the current position, what we will do, we will change current to the furthest position. Okay? In this way, we can get the total number. So here we use a pair to store the segments. So we have a vector of a pair int. We call that segments. So we can initialize them. So for I equals 0, I less than range's size plus I. Segments will push back. What will be pushed back? So I minus ranges I, right? I then plus ranges I. And then we will sort it. Okay, now they are all sorted based on first sort by left hand, then sort by right hand. Then we define two items. One is the current position starting at 0, and the next position starting at -1. I think you can make it starting from 0 as well, but it doesn't matter. And return value is the total number of tabs needed. Then we start from first position until the last position. I less than segments size. Yeah, auto segments. It equals to segment I, right? And there are several conditions. The first is the second of segment will less than current. In this situation, do nothing. Okay. The second is the current segment. Current position is in between the two ends of the segment. So first, less equal to current, and current less than second. In this situation, we don't change the current. We will update next. Next will be max next, and second. Okay. And the third situation is just segment second will be less than no, second current will be less than the first of the segment. In this way, the segment cannot cover current. Then we will need to update. We will update. So if next is larger than current, okay? So if this condition is not met, it means we cannot move forward. So there are some parts cannot be covered. We'll just return -1, okay? And if next is larger than current, then we can update. And is there anything else we need to do? Yeah, we need to plus the res. Okay, and after we move it forward, we actually need to reconsider the current segment again. So we put I minus minus here. And after we do the for loop, if the current is still less than segment size, this means we need one more to cover than res. Okay, so I think we'll just submit. Yeah, it passed. So the key point is we need to change those ranges into segments. So then we are facing some familiar problem we have been dealing with for a long time. Then the segment will be sorted based on the two ends. Then we can just update. Okay, and I think for the first implementation, you might miss this condition, but after a few try, you will add it back. And you may also miss this condition. This is important because after you do this update, you actually need to reprocess this current segment again. So you need to put I minus minus because I will be updated here. Okay, and I think that's it for this question. And thank you for watching. See you next time.